Hello everyone. Now we're going to do another multiplication problem demonstrating that organized method that I like so much. So I'm just going to give myself plenty of room because last time I tried to record this video I ran out of room and it looked too sloppy. So we're just going to set it up like this. That should be enough. Alright. Where we write out our polynomials based on the locations of their exponents. So for example, I don't know, I'll say this is where my constant's going to go. This is where my x term's going to go. Then I have my x squared, x to the third, x to the fourth, x to the fifth, x to the sixth, x to the 7, x to the 8, x to the 9, although I don't think we're going to need that. So let's write out that first polynomial we got here, where 1 is my constant, so it goes in a 1 spot. And then we have our negative 3x to the 4, which goes in the x to the 4th spot, negative 3x to the 4. Oh, and I always try to note that it's positive or negative. And then 3x to the 5th goes in the x to the 5th spot. So plus 3x to the 5th. Now I write down my other polynomial where 6 is the constant. We have positive 6. X goes in the x column, which is a positive. Then we have negative 2x squared. And finally, x to the third, which is a positive. And now we can kind of treat it like a standard multiplication problem, where we have, alright, 6 times 1 is 6, and that will remain in the constant column, 6. Then we have 6 times negative 3x to the 4th. Well, 6 times negative 3 is negative 18, and that's going to remain in the x to the 4th column. So negative 18, x to the 4th. And then 6 times 3x to the 5th is positive 18x to the 5th. Now I multiply everything with x. So x times 1 is just x, and that's going to stay in the linear spot. I'm just going to put a row down so I know it's the next thing I'm multiplying. Then we have x times negative 3x to the 4th. That would become negative 3x to the 5th power. So we have to move that to the 5th spot. Then I have x times 3x to the 5th. That would be positive 3x to the 6th. So now it's in the x to the 6th spot. I should note this is a positive as well. And now I can move on to the next step. So negative 2x squared times 1 is negative 2x squared. So drop that down, negative 2x squared. Then we have, let me erase that, negative 2x squared times negative 3x to the 4th, which would be, well, negative 2 times negative 3 is a positive 6. X squared times x to 4 is x to the 6. So 6x to the 6. Then we have negative 2x squared times 3x to the 5th. Well, negative 2 times 3 is negative 6. X squared times x to the 5th is x to the 7th. So we have a negative 6x to the 7th power. Then finally, we got x to the 3rd times 1, which is just x to the 3rd. So that's going to go here, x to the 3rd. Then we have x to the 3rd times negative 3x to the 4th, which would be a negative 3x to the 7th. And then x to the third times 3x to the fifth is a positive 3x to the eighth. Let's put a plus there, a plus here, plus here. Okay, now let's extend the page a little bit now that we're done with that. Now, time for the addition part. Now the addition part is relatively straightforward. We're just going to add down the column. So my only constant is a 6, so I put a 6 there, plus 6. My only linear term is an x. My only x squared term is this negative 2x squared. Plus, my only x to the third term is just x to the third. Then my only x to the fourth term is negative 18 x to the fourth. Then we have 18x to the 5 minus 3x to the 5. That would reduce down to 15x to the fifth power. 3x to the 6 plus 6x to the 6 is a 9x to the 6th power. Then negative 6x to the 7 minus 3x to the 7 is negative 9x to the 7. Put a plus. And then finally we have our 3x to the 8th power. And that, since we have now combined everything together, gives us our entire answer. Long as it may be, we get our accurate answer of 3x to the 8th minus 9x to the 7 plus 9x to the 6 plus 15x to the 5th minus 18x to the 4 plus x to the 3rd minus x squared 2x squared plus x plus 6. So keeping organized like this is a very, very useful tool for helping us solve these longer multiplication problems.